Okay, let's start a lesson on solving systems of equations using elimination. I've got some steps that if we follow, it shouldn't be too bad. So step one is, are the equations both arranged in standard form? So standard form is when we've got the term with the x in it, then the term with the y in it, then the equal sign, and then a plain old number without an x or a y. So yes, that's true. Step one, both equation 1 and equation 2 are in standard form. So we get to move on to step 2. So we call this method elimination because we are trying to eliminate either the x terms or the y terms. See if you can eliminate by adding or subtracting the equations. So let's look at this. If we add this first equation to the second equation. I know this looks weird. We've never done addition like this, but look what's going to happen. We'll have 5x plus 4x. Well, that'll be 9x. And then 3y plus negative 3y. If you put 3 minus 3 in your calculator or 3 plus a negative 3 in your calculator, you're going to get 0. It's gone. We eliminated the terms with the y in it. We bring down our equal sign. 16 plus 2 is 18. And now we have a simple equation that we can solve. We go ahead and divide both sides by 9, and we get x is equal to 2. Now we're almost done. We need to, a system, when you solve it, remember, think about two lines that intersect. It's going to be a point, so we need a value for x, and we need a value for y. And so what we're going to do is we're going to plug that 2 in for x. We could plug it into either equation. I'm going to go ahead and plug it into the first equation. And so what that means we're going to do is we see a 5, we write a 5, we see an x. Nope, we know x is equal to 2, so we're going to plug that in. Then we're going to rewrite the rest of the equation. And now that we have an equation just with a y, we can solve for it. So 5 times 2 is 10. That's our first step. And then to get y alone, we're going to subtract 10 from both sides. So then we'll have 3y is equal to 6. Then we'll divide both sides by 3. Let me move this. Let's check your answer to the side. Okay, so we get y equals 2. And when you write your answer to a system, you're going to write it as a coordinate point. So you'll put your x value first, 2, and then your y value. Well, they're both 2. The answer to what does a ballerina wear? All right. So if we had graphed these two equations on graphing paper, we would see that they would intersect at the point 2, 2. So pretty cool. Another example of solving systems using elimination is this. So once again, we're going to go through these steps. Step 1, are they in standard form? Yes, they are. Both equations are in standard form. So then we're going to go to step 2. See if you can eliminate by adding or subtracting. So the last problem we just did, we could add and eliminate. In this problem, can you see that if we subtract, that then our 3y and 3y will cancel out? So let's say 5x minus a 2x is 3x. The hard thing about subtracting one equation from the other is you have to remember to keep subtracting as you move down the equation. So we'll have 3y minus 3y, which if you put 3 minus 3 in your calculator, you'll see it goes away. It's a 0. So we bring down our equal. Then 8 minus a 2 is 6. So once again, we're left with an equation that we can solve. And we get that x equals 2. Remember, when we solve a system, for a system, we are going to end up with two answers. We're going to end up with one for x and one for y. So what I'm going to do is, I know that x equals 2, so I'm going to go back to the first equation. I could go back to the second equation. I just kind of trying to make it understandable with all these curves. And I'm going to plug in 2 when I see x. If I plugged in 2 when I saw x to the second equation, when I solved, I'll get the same answer as I'm going to get right now. So 5 times 2 is 10. We're going to subtract 10 from both sides. And we get that 3y is equal to negative 2. So one more step. We're going to divide both sides by 3. Move this. And we'll get that y equals negative 2/3. So we're going to put it together because a system solution is a coordinate point. Here my x is 2 and my y is negative 2/3. So the point 2 comma negative 2/3 is the answer. Okay, so this next one, we're going to go through our steps. Is it in standard form? Yes, both of them have the x term, then the y term on the left side equals a number without a variable. Okay, step 2 says, well, can you add or subtract to eliminate either the x or the y? And you know what? It's pretty obvious we're not going to, because when we look at the number in front of the x, both x's, no, 8 and 12 are not, or 8 and negative 12 are not going to cancel out no matter if you add or subtract them. 6 and negative 9, same thing, not going to cancel out no matter if you add or subtract. So we're going to have to move past step 2. And so step 3 says, does a number divide evenly into all 3 terms in equation 1? So we look at 8x, we look at 6y, we look at negative 20, and we say yes. 2 goes into all 3 numbers. So we kind of make a note to ourselves that we're dividing by 2. And as long as we do that to all 3 terms, we're going to be fine. So 8x divided by 2 is 4x. 6y divided by 2 is 3y. And negative 20 divided by 2 is negative 10. Once again, remember to divide every single term, all 3 terms, by that same number. And so now I'm going to look at the second equation. Is there a number that goes into all 3 of those terms? Yes, a 3 goes into it. So we're going to divide all 3 terms by 3. So here we go. Negative 12x divided by 3 is negative 4x. Negative 9y divided by 3 is negative 3y. And 30 divided by 3 is 10. Okay, these equations are looking quite similar. So let's see what's going to happen. Let's go ahead and add them together. I choose adding because I see that the signs of the x's are opposite each other and the signs of the y are opposite each other. So I'm going to pick to add. 4x plus negative 4x, that's the same thing as 4 minus 4. It's gone, eliminated. 3y plus negative 3y, or if you want to think about it as 3y minus 3y, eliminated, gone. When both of them are gone, just like when the cookies are gone from the plate, how many cookies do you have left? 0. How many x and y's? You have 0. And then we've got negative 10 plus 10, which is 0. So when x and y both leave the scene, then we're left with a choice to say either infinite solution or no solution. So when I look at this, I have to ask myself, does 0 equal 0? And I say yes. So I know if I say yes, then the answer is infinite solution. If we graphed these 2 equations on our graphing paper, oops, forgot the O in the solution. If we graphed these, they would actually end up being the same exact line. Pretty cool. And when that happens, we've got millions of places. There's an infinite amount of points where these 2 lines would intersect because they end up being the same line. And then we'll have something like this, where yes, they're all in standard form, so we can skip step 1. Step 2, we know that we can't just straight up add or subtract. The only time we can do that, when you look back at the first 2 problems that we did, we knew we could add or subtract because see how we had the positive 3y and the negative 3y? We could see that those would cancel, and it's the same number but the opposite. Same thing here. We had a positive 3y, a positive 3y. There's the same number, and if we subtract it, they would cancel. But we couldn't just add or subtract here because 8 and negative 12 aren't the same, and 6 and negative 9. So we couldn't do it there. And so same thing here. We can't just add or subtract. We're going to have to do a little bit of work. So let's go to step 3. And step 3 says, hey, is there a number that goes into 4, 5, and 7? No. Besides the number 1, and we're not going to do that. And same thing with equation 2. 3, 1, and 10, nope, there's not really a number that goes into all of them. So we're going to have to venture into step 4. And step 4 says, if step 3 didn't work for you, you must make a wish, then make it come true. All right, so when I'm looking at these 2 equations, I'm thinking about what my wish is going to be. I wish that this guy right here was a 5y, because if you were a 5y, then the y's would cancel out. So that's my wish. I wish that instead of having a y, I would have a 5y. And now the making it come true part is you ask yourself, what could I multiply y by to make it a 5y? And yes, I can hear you say, multiply it by 5. So I'm going to multiply every term in this second equation by a 5. And so 5 times 3x is 15x, 5 times y is 5y, and 5 times 10 is 50. I need you to understand that both this green equation I just wrote and the original equation here, they're actually the same equation. It's just one is in disguise. But if we graph them, they would be the same line. I haven't changed anything, just made it look a little different. And so now we're going to take this other equation and rewrite it because we want them to be close to each other when we choose to add or subtract so we don't make mistakes. And now what are we going to do? Are we going to add or subtract? Well, since the positive 5 and the negative 5 are going to cancel out because they're opposite signs, we're just going to add. We don't need to subtract. So here we go. 15 plus 4 is 19, so we have 19x. 5y minus 5y, that cancels out, so it's gone. And 50 plus 7 is 57. All right, and then we end up with a simple equation, which we're going to go ahead and divide both sides by 19. And we see that x is equal to 3. We're not done. We've got to go ahead and take this 3, and let's plug it in. I'm just going to plug it into the first equation because I keep doing that over and over again, don't I? I could have plugged it into the second, but when I see x, I'm going to go ahead and plug in 3, just like we did when we were doing substitution. Once we find that first answer, we're doing the same exact thing as we did when we found the first answer in substitution. So here we go. We're going to go ahead and say 4 times 3 is 12. Then we're going to subtract the 12 from both sides. And divide both sides by negative 5. And we'll get that y equals 1. So our answer, once again, when we're solving a system, our answer is a coordinate point where the x value goes first and the y value goes second. And if we graph these two equations on graphing paper, that's where the two lines would intersect at the point 3, 1. Okay, so, oh my goodness, this is the first time we're going to have to do step 1. Step 1, it says, are the equations both arranged in standard form? Well, the second one is, but the first one isn't. So what we're going to do is we're going to take the first one and we're going to rewrite it. So I'll rewrite it, and I know that I want to move that 4x and make him be on the left side of the equal sign. The only way I'm allowed to move anything is if I do the opposite. So I see 4x, and if I move it, I'm going to be subtracting 4x. And then note, I can't combine 7y minus 4x. I wouldn't want to anyways because I want both x and y to be there, so I'm going to rewrite it like this. These canceled out, and I have a 12. So now this is my new equation that I'm going to use. Sometimes when we start messing around with each equation, we have to remember, all right, which one am I going to use? And sometimes I just stop and put a rectangle around the ones I know I want to use. All right, so I'm looking at my second equation, and I could ask myself, I'm going to look at step 2, and I know straight up if I'm going to use the second, if I'm looking at the second equation, I know that the second equation and this equation that's in the rectangle are not going to cancel out just by adding and subtracting. Nothing's going to be eliminated. So I look at step 3. I'm going to put my blue marker down. So I'm looking at step 3. I have a choice. I could look at this equation right here, and I could go ahead and see that 2 goes into every single term, and I could go ahead and divide by 2, or I could take this equation and make a wish and multiply it by 2. Either way will work. So I'm going to go ahead and I'm going to decide to divide this one by 2 and rewrite it. So 8x divided by 2 is 4x. And negative 14y divided by 2 is a negative 7y. And negative 22 divided by 2 is a negative 11. All right, I see since I have negative 4 and positive 4, these guys are going to cancel out if I add. Right, it's supposed to be an addition sign there. So a negative 4x plus 4x, gone. 7y plus negative 7y, gone. Oh my goodness. Now things left on the left side. 12 plus negative 11 is 1. All right, when x and y leave the scene, I have to ask myself if the statement left over is true or not. So I ask myself, does 0 equal 1? No, of course it doesn't. So my answer is no solution. And if we took these two equations and we graph them on the graph, we would find that they are both parallel. They're parallel lines. They're never going to intersect. Therefore, they have no solution. Okay, let's look at the next one. They're both in standard form, so we're done with step 1. Step 2, we can see that we're going to have to do a little bit of work before we can just jump straight to adding or subtracting. So we look at step 3, and we see that we can certainly reduce. We can simplify both equations. When we look at the first equation, we can, let's see what goes into 9, 6, and 18. 3 does, so we'll divide everything by 3. So 9x divided by 3 is 3x. 6y divided by 3 is 2y, and negative 18 divided by 3 is negative 6. Once again, the green equation I just wrote and the original equation, 9x plus 6y equals negative 18, it's the same. It might look different, but if I were to graph these two equations, it would be the same line. So that's what we're really doing. We're having fun. I think it's fun at least. We're having fun with each equation to see if we can write it a little differently and work with it so that we can solve the system. So we'll look at the second equation and we'll say, okay, what number goes into negative 4, and 30? Well, the biggest number is going to be 2. Sometimes it's good to divide by the biggest number you can find. Sometimes you have to get a little strategic about what number to divide. But in this case, 2 works. Negative 4x divided by 2 is negative 2x. Negative 4y divided by 2 is negative 2y. And 30 divided by 2 is 15. So we can see, because we've got a 2y and a negative 2y, that adding the two equations together will work. 3x minus 2x is just an x. I could write 1x, but I'm going to write x. 2y plus negative 2y, they're gone. And then negative 6 plus 15 is a 9. So we've got x equals 9, but we're not done, are we? All right, we have 4 equations to choose from. I could take this, let's see, I could take this 9, I could plug it into any of the 4 equations. I'm just going to go ahead for simplicity's sake and plug it into the original one. So as I move down here, I've got 9, and then 9 plus 6y equals negative 18. And I'm going to go ahead and solve it. So I have 81 plus 6y equals negative 18. And I'm going to move the 81 over. I'll get the 6y equals. Let me move this. Okay, so that will give me negative 99. Does 6 go into negative 99? I'm not sure. I think it's going to be, I don't have a calculator up with me. Oh, you're going to have to watch me do this longhand. So let's see. 6 goes into 9 one time. It goes into 39 6 times with 3 left over, so that's a 0.5. All right, that's the way we used to do math with, when we didn't have calculators around. So 16.5 is y. Once again, when you solve a system, you write it as a coordinate point where you put your x number first and your y value second. And so if we were to graph these two lines, that's where they would intersect. And it would be hard to actually discover this answer just by graphing. That's why solving with substitution and solving with elimination is great, because you can get the exact answer. All right, here we go again. Are they both in standard form? Yes. Can we just add or subtract? No, we're going to have to have fun with this. All right, let's see if we can just go ahead and simplify. I'm going to simplify the first one by dividing by 2, because 2 goes into 6x, 3x times, and 2 goes into 4y, 2y times, and 2 goes into 2010. And then I'm going to look at this, and I know that 3 goes into every single one of these terms. So I'm going to rewrite it as negative 3x minus 2y. Oh my goodness, another one of these. And I can see that I can add them, and all sorts of things are going to cancel out, aren't they? 3x minus 3x gone. 2y minus 2y gone. When everything's gone, don't just leave it blank. Don't put a 1 there. When everything's gone, there's nothing left. And when there's nothing, the number that represents nothing is 0. 10 plus 4 is 14. And I have to ask myself when x and y leave the scene, is this a true statement? Does 0 equal 14? No. And so I find myself writing no solution. So if we graph these two equations on a graph, they would be parallel lines. I knew you were saying it before I even did. Okay, and that's it. That's a nice little tutorial for how to use elimination to solve a system. Sometimes you'll have to make a wish twice. Sometimes you might have to simplify and make a wish. So don't give up. Keep trying the different steps and you'll get there. Good luck and have fun.